Hey, I'm Michael. Welcome back. If you missed our first episode, we talked about our purchase, taking the body off of the Jeep. We removed everything with the exception of 2 cross members and the body mounts. Everything else got stripped off. And if you would like to see that from the very start, be sure to get our first episode. In this episode, we're going to be talking about setting the ride height, basically just sticking this giant coilover as far up into the fender well as we can, and then hope everything else works. And then we're going to be checking for axle width, what we need to build out to be able to fit the clearances for the 40s, and to be able to fully articulate with steering, turning both ways, articulating everywhere. We'll be doing a whole bunch of housing and axle work, including billet ends and knuckles. We hope you enjoy the episode. Let's get to it.
We ended up last time by setting the body on the frame. Now we're moving forward in setting the ride height, as well as confirming the front and rear end width. Our goal was to keep the center of gravity as low as possible, yet still achieve full suspension articulation. In other words, we don't want to overlift the body and end up top heavy. After mulling over the various components, the coilover placement, the wheel and tire width and offset, and the suspension articulation, we settled on a 72-inch wide wheel mounting surface to wheel mounting surface for both the front and rear end. The housing build started by sawing the tubes to length and welding them into the housing centers. We opted to install the rear billet ends and front knuckles after the bracket installation and housing pre-straightening. Now it was time for the housing placement. According to GenRight and various other Jeep JK builders, the rear end should be pushed back 1 inch and the front end forward 1 inch for a longer wheelbase and best all-around handling. We were shocked at the amount of measuring and fussing that is needed to get the housings just right compared to each other, centered to the body, and perpendicular to the frame so it doesn't dog track going down the road. We use carefully placed plumb bobs for measuring references and 2 guys to do the measuring. Measure twice and cut once, as they say, whoever they are. As mentioned before, any brackets we couldn't source had to be designed and made in-house. We were able to purchase the lower control arm brackets. However, they were designed for a 3-inch tube, and our build is using a 3.5-inch tube. Rather than grinding them to the 3.5-inch diameter tube profile, we decided to fly cut them on our Bridgeport mill. When it came to the upper control arm brackets, coilover mounts, and front track bar bracket, we couldn't find the shape and size we wanted. We opted for custom designing them the exact way that works best for our setup. After a little CAD design and some laser cutting, we had the brackets we needed. To position the lower and upper control arm brackets on the housing, we used a laser pointer to line them up. Because the only part that could be purchased was the pointer itself, we machined some round stock to the same width as the rod end and threaded the ends so they could be bolted in place. The bar that holds the laser pointer was installed in the crossmember brackets, and the housing bracket bar had a dimple machined in the center of it for visual alignment purposes. Super simple, and it worked great. After some additional mock-up and measuring, we determined where the coilover mount should land and simply centered them up to the tube ends. Once all the brackets were tacked in place, we measured the control arm lengths, removed the housings from under the Jeep, and proceeded with the finished bracket welding. Next up was fabricating the custom control arms. For strength reasons, we used 2-inch by 1/4 wall DOM tubing along with weld-in threaded tube inserts. In order for the control arms to be adjustable, Right and left-hand inserts were installed at opposite ends. Each insert has a machine hex on the end, making any adjustments easy. With our predetermined measurements, we cut the DOM tubing to the correct lengths. Then we faced and machined the weld prep on both ends. With the machining done, we installed the inserts and welded them in place. Once the control arms cooled off from welding, we added the finishing touch and machined the welds smooth, blending them into the tube OD. Even though it wasn't necessary, we absolutely wanted this blended look for a wow factor after powder coating. The next step was to clean out the threads by running a tap in each end and installing the Johnny joints with some anti-seize compound. At this point, it was back under the Jeep with the housings and assembled control arms for more measuring and bracket work. Having the housings connected to the control arms gave us the ability to articulate them within the Fox coilover travel limits, as well as set and install our upper control arm mounts at the correct height in relation to the frame and housing brackets. To accomplish this, we took 1-inch thick wall DOM tubing, cut and threaded it to accept rod ends on both ends. Then we adjusted them to the required center to center that will be used at ride height. Knowing what measurements the Fox coilover travel limits were, both fully extended and compressed, we also made solid strut rods for full droop and bump, totaling 3 different combinations. Doing this allowed us to confirm the various travel limits so we could correctly set the bump stop and limit strap brackets. We also made sure that neither brackets nor control arms were binding or causing interference. Once we finished tacking the rest of the brackets, we unbolted the control arms and took the housings back to the weld room for the final bracket welding and installation of the rear billet ends and front knuckles. The rear billet ends were not originally designed to be used with an ABS sensor, which unfortunately is something the Jeep computer system requires to even drive the vehicle. So before we installed the billet ends, we machined the necessary ABS sensor pockets. Once machined, we slid them onto the housing tubes, set the pinion angle, then welded them in place. Our front housing design incorporated a pair of SpiderTrax Ultimate steering knuckles. We really like the high quality, sturdy fabricated design, as well as the feature of high-load uniball spherical bearings for the rotational steering chores. Installation of these were similar to the rear billet ends. Slide them on the tubes, set the pinion angle, and weld them on. After the housings cooled from welding, we used a bar jig to check them for straight. Just as we thought, they needed a little tweak on both sides. Anytime you weld brackets on a housing, you increase the chance of warping the tubes. We used our big hydraulic press for the pre-straightening and some old school heat shrinking for the final straightening and the fine-tuning of the housings. This is critically important to avoid wearing out wheel bearings, axle and or drive flange splines, or the differential components prematurely.
That's it for this episode. We hope you like, share, and subscribe. Stay tuned for the next one. And I think this coffee gave me some diarrhea. Just he said.
People at home don't need to know about that.
Whispering weird obscenities to the cameraman just to check if the mic's on.